Today we are going to be going over function rules. Our content objective is students will be able to calculate inputs and outputs and also finding function rules. Language objective is students will be able to verbally use correct vocabulary when discussing function rules. And last but not least, why am I learning this? Well, it's important for solving real-world problems like calculating how much money you will earn working a certain amount of time. So first of all, I want to talk about something called a function machine. Basically, when you have a value for x, which we've called the input, you put it into the machine, a value y is going to come out, which we are going to refer as the output. So here we have a function. This is the machine. First, I always start with an input. So if I put a 2 into the machine, I'm going to end up with an output of 13. Okay, so just a friendly reminder, your input is x and your output is y. Now, if with the same machine, if I put in a 3, I get an output of 20. Okay, so same machine, if I have an input of 4, my output is 27. So the question is now, what happens if my input is a 7? If I run it through this machine, what will it be? Well, it's going to be 48. So now you're probably wondering, okay, so what is this machine doing to the input to get these outputs every time? Well, in this case, this machine is doing the same thing every single time, so the function rule must be consistent between all of the inputs and outputs. So it's going to be y equals 7x minus 1. This is what we refer to as the function rule. Okay, the rule describes the relationship between x and y. So here, in other words, you're getting y, your output, by taking 7, multiplying it by the input, and then subtracting 1. So for example, 7 times 7 is 49, minus 1 is what's going to give you 48. Okay, so now if you want to arrange it, you can arrange it into a table. So 2 gives you, input of 2 gives you an output of 13, input of 3 gives you an output of 20, and so on. Okay, so in this case, oops, I kind of went ahead of myself. If they ask me, okay, if you input a 5, what would your output be? You're plugging your 5 into the function rule for your input. So 7 times 5 is 35, minus 1 would be 34. What if your input is a 6? Again, you'd use the same function rule. It's going to be 7 times the input of 6, which is 42, minus 1, which would give you 41. And 7 we already have as 48. So the function rule is going to allow you to figure out any output you'd like depending on whatever input you have. Okay, so here is another function rule. This function machine is going to take your input, multiply by 3, and then add 1. So if I have an input of, let's say, x equals -3, what's going to happen is this input's going to go inside the machine. It's going to use the function rule. So in other words, you're going to be plugging in a -3 in for x. And you're going to get an output. Y is going to equal 3 times -3, which is -9, plus 1 is going to give you a -8. So this is what our output would be. Okay, so now what if we have a different function rule and we put an input of 2 this time? So again, this input is going to go inside the machine. It's going to follow the function rule. So you're going to put a 2 in for x, and you're going to simplify. So here you have to do exponents first. 2 cubed is going to be 8. 8 plus 1, take the square root of that, gives you your output of y. I'm going to simplify it one more time. 8 plus 1 is 9. The square root of 9 is 3. So your output of y is 3. So all you're really doing is substituting your input into the function rule to get an output. Okay, so now let's try using the function machine twice. So let me give you an example. Here, if I have an input of 1, it's going to go into this machine first. So I'm going to say, okay, y equals the absolute value of 3 times the number, x, which is going to be 1, minus 8. So now I'm going to go ahead and do multiplication first. 3 times 1 is 3, so I have 3 minus 8. Take the absolute value of that to get the output. I'm going to get y equals the absolute value of negative 5, which is going to give me 5. So now that I have this output of 5, it's now going to become the input into this second machine. Okay, so here, now I'm going to be plugging in this case, x equals 5. So that's going to be my input now. So 5 goes inside the machine. Oops, let's take away this real quick. And I'm going to plug it in for x, say 5. So here, y equals a negative 5 plus 6. And that's going to give me y equals 1. So my output is 1. So essentially, you need to take the input, figure out what the output is, and that output becomes a new input, and you repeat the process. Okay, so now what I want you to do is you're going to try number 4 all on your own. So you're going to go ahead and use the function machine about 3 times to get your final answer. So the first piece of information you're going to need to know is what's your input. And in this case, your input is x equals negative 2. So go ahead, pause the video, and see how well you do. Okay, so we're back. So let's see how you did. So first things first, you're going to go ahead and input a negative 2 in for x. I'm going to say y equals parentheses. Instead of x, I'm going to go ahead and put a negative 2 there, minus 4, and that's going to get squared. So this is going to be negative 2 minus 4, which is a negative 6. I'm going to square this, and that's going to give me 36. So 36 is my output, but now I'm going to put it into the machine, so then it's now an input in this case. Okay, so 36 is going to go on this side of the machine, so y equals 2 times x, which is 36, minus 75. So this is going to be, let's see, 72 minus 75, which gives me negative 3. So negative 3 is my output, but once it goes in the machine, it becomes an input. So here, I'm going to repeat it one last time. Y equals negative 5 times the input, which is negative 3 minus 12. This is going to give me 15 minus 12. So my final output is going to be 3. So hopefully you did that one right. If not, go ahead and take a look and see where did you make a mistake so that you can fix it in your notes. But that's the final answer. Okay, so we're just going to go ahead and move on. Now moving on to number 5. It says write a function rule for each table. So here we have our x's and our y's. Again, just a friendly reminder, x is our input, y is our output. Now another terminology you can use is independent variable and dependent variable. I am going to go into the definition of these vocabulary words in a second, but for right now, I want you to focus on our values. We got an input of 2, output of 8. Input of 4, output of 10. Okay, what I want you to do is try to think of a function rule. You're thinking right now, what can you do to 2 to give you an 8? And does that rule apply to starting with the 4 and getting a 10? Okay, so for example, a lot of students might say, oh, 2 times 4 gives you 8. And that's totally true. However, does 4 times 4 give you 10? No. So you need to make sure this function rule works for all of these different inputs and outputs. So in this case, if you figured it out, the function rule was to add 6 to your input to get your output. So here, you're going to take y basically equals x plus 6. So how would I write that? As a function rule, I would write that as y equals x plus 6. So this is my function rule. Y equals x plus 6. Okay. Now let's take a look at the vocabulary a little bit more. So here, we have the dependent variable and, we have an independent variable and a dependent variable. A lot of students tend to confuse the two, so I want to talk about it a little bit so that we can make sure we remember. So first of all, Input, just a friendly reminder, is your x values, and your output is your y values. Now, something that you need to understand, okay, is the fact that your output, aka your y values, depends on what you input for the x values. So the only way we generate an output is by depending on the input. Okay, so keep that in mind. Your x value is derived from your y value. Your y value is dependent on your x value. Therefore, y is your dependent variable. Okay, so now taking a look at number 6, I want you to figure out what the function rule for this table is. Okay, you do have a graph in front of you, so if you can't figure out the function rule off the top of your head by guessing and checking, what you can do is go ahead and plot these points onto your graph and figure out what the function rule is based off of the graph that appears. Okay, so let's check it out. Hopefully your answer was that the function rule is you have to take the input, multiply it by 2 to give you the output. So here, the function rule would be y equals 2x, okay? Because every time, hopefully you notice, the input values were doubled to give you the y value. So here the function rule is y equals 2x. Now, something that I want to talk to you about is taking a look at this function rule. Is it a proportional relationship? This is something you learned from 7th grade last year. Hopefully your answer is yes. And why, you might say? Well, because it's in the form of y equals kx, or now at this point we can even say it's in the form of y equals mx, slope times input. And graphically speaking, what do we expect to see? We expect it to be a straight line. Also, we expect for it to go through the origin. Right here is proof that it does go through the origin. So you might want to keep an eye out for those ordered pairs to see if it does. Okay, so now take a look at number 7. Go ahead once again, go ahead and pause the video and try this one on your own. If you can figure out the function rule by looking at the table, awesome. If you can't, you can use the graph in front of you to plot the point to see what the function rule is off of that as well. Okay, so let's see how well we did. So the function rule was y equals 3x plus 1, which means you're going to triple your input value and add 1 to give you your output, okay? So for example, 3 times 0 is 0 plus 1 equals 1. 3 times 2 is 6 plus 1 is 7. So it definitely works. So now the question is, what would the graph look like? Okay, so if you couldn't figure it out just looking at the table by itself and guessing and checking, you could have graphed these ordered pairs. Obviously, this one won't fit on your graph, but however, these 3 will. And you can see, oh look, okay, this is your y-intercept, hence plus 1. And then what was your slope? Well, it's going up 1, 2, 3, over to the right 1. So that's a vertical rise of 3, horizontal change of 1, which gives me a slope of 3. That is your slope. So again, you can always use the graph to help you out to figure out the function rule if that's helpful. But the last question that I'm going to ask you now is this a proportional relationship? Why or why not? Hopefully your answer is no. Why? Because it doesn't go through the origin. And here's the proof. Okay, when x equals 0, y equals 1. That's not the origin. Okay, the y-intercept occurred at 0, 1. Therefore, obviously, it doesn't go through the origin. Okay, so now moving on to number 8. Again, go ahead and pause the video and try this one on your own. Definitely use the graph if you need to try to figure it out graphically. Okay, so let's see how well we did. The function rule for this table is going to be y equals x minus 8. So hopefully, for some of you, you may have been able to look at the table and saw that every single time you were subtracting 8 to get the output, every time, okay? But if you couldn't, you could have graphed it. obviously this ordered pair wouldn't fit, nor this two, but these two would have been enough for you to see, look, the y-intercept occurred at -8, which by the way, you could have recognized here. Okay, you could have seen, oh look, b equals -8. And the other thing was the slope. Look, it's rising 1, running 1. So your vertical change is 1, horizontal change is 1. So your slope is a 1x. We just normally don't write 1x, just put x by itself. So hopefully you're able to get the function rule either just looking at the table, guessing, checking, or if need be, graphing it. Okay, so number 9. Okay, go ahead and pause the video and try this one on your own. Let's see how well we did. Hopefully you saw that the function rule is y equals -2x plus 9. Make sure your function rule works for each and every ordered pair, because you might come up with one that may only work for the first but not the second, so you got to be careful. So here, if you were to graph it, this is what it would look like. All of these ordered pairs would fit on your graph. Here you can see that the y-intercept occurred at 0, 9. So this one you couldn't see from your table, but if the y-intercept is 0, 9, I can confidently say that b is 9, hence that +1. And the slope, look, there's the vertical change of -2, horizontal change of 1, which gives me a slope of -2, and that's how I got this number here. So again, sometimes it can be a little bit difficult just guessing and checking, okay? So if need be, definitely just go to graph it and see if that helps. The only disadvantage with graphing is if all of your ordered pairs are too large and they can't fit on your graph, then you're going to have some trouble there. So you want to be able to do both. Look at a graph and get a function rule, and look at a table and get a function rule as well. Okay, so the last two I'm just going to go over with you for this one here. What is happening for us to get from -1 to -7, from 0 to 0. Wait, first of all, I notice this graph would go through the origin, which tells me this is a proportional relationship. So it should be in the form of y equals kx. So now it's just a matter of figuring out what is k, or in other words, we can also say y equals mx. So what is slope? How do I get from 1 to 7? Multiply by 7. How do you get from 2 to 14? Multiply by 7. How do you get from -1 to -7? Multiply by 7. So here, this function rule is actually a lot easier than the rest. My function rule would be y equals 7x. Graphically, this is what it would look like. It does go through the origin, which I would expect because of the table here. And then you can even see here that the slope would be 1, 2, 3, 4, 5, 6, 7. So there's a vertical change of 7 and a horizontal change of 1. So that would be the slope represented here. Okay, so we just have one more to go. Okay, just a friendly reminder, this is a proportional relationship. Why? Because it's linear and it goes through the origin. So let's backtrack real quick because I forgot to mention it in the other slides. Here's number 9, a proportional relationship. The answer is no. Why? Because it doesn't go through the origin. Okay, and what about number 8? Is this a proportional relationship? No, because it doesn't go through the origin. And I think there was one last one that we didn't talk about. Number 7, is this a proportional relationship? The answer is nope, because once again, it does not go through the origin. Even though it is linear, it needs to also go through the origin. Okay, for the last problem here. So I'm trying to figure out the function rule. So I'm trying to figure out what am I doing to -1 to give me -17. Let's see, I could subtract 16. But notice 2 minus 16 is not going to give me 1, so that doesn't really work. What else could I do? How can I get from 2 to 1? I can multiply by 2, subtract 3, but would that work here? No. So this one, you can kind of see it is a little bit difficult to figure it out. So what could you do? You can graph this one. Let's Notice when I graph it, I can see a little bit more. Well, first of all, I can see what the slope is. Let's see. Let's pick 2 points. I see this point here, and I see this point here. So what's the vertical change? 1, 2, 3, 4, 5, 6. So my vertical change is 6. My horizontal change is 1. So my slope is 6. So it's definitely going to be in the form of y equals 6x. So here, all I need to do is find out where the y-intercept occurred. It's kind of tricky, but it seems like it's occurring right here at -11. So I'm going to say -11 because that's B. But let's just check if this works real quick. What is a -1 times 6? That's going to be -6. -6 minus 11 is -17. That works. 6 times 2 is 12. 12 minus 11 is 1. That works. 6 times 1 is 6. Minus 11 is -15. That works. Sorry, -5. Here, 6 times 6 is 36. Minus 11 is 25. So this works as well. So notice if it's difficult for you to just look at the table and try to find the function rule, you always have a graph as an option. Just understand that a graph could be limiting as well, because notice this didn't fit on the graph, nor did this. So you would at least need 2 points to be able to figure it out. If you only had 1 point really wouldn't help you. So just keep that in mind. So you want to be able to do both, looking at a table, guessing and checking, as well as graphing and recognizing those important features, which is the slope and the y-intercept. So I would say here, the function rule is y equals 6x minus 11. So that is going to conclude our lesson for today. Thank you so much for tuning in, and like always, until next time, bye.